Hi, welcome everyone. We are discussing the natural gas process engineering, and today is the lecture number three or chapter number three. And in the previous chapter, we just generally discussed about the natural gas processing. We talked about the impurities it has. We talked about the various processes it has, and starting from the field operations to inlet receiving to the dehydration to uh, to the amine process, sweetening process, to remove the heavy hydrocarbon and so on. So today we are starting the one by one each of the sections of the natural gas processing. The first part that we will touch is the field operations, and let's see how it all goes. So in this lecture, we'll talk about the wellhead operation, we'll talk about what is piping, we talk about the compressor stations, pigging, and the separators and slug catchers, and in the end we talk about the gas hydrates and why it is important to work on the gas hydrates. First of all, this is the block diagram of the gas processing. Well, first of all, the basic process starts from the inlet receiving. Inlet receiving is the first step after you produce the gas from the reservoirs, goes through the separator. Separator separates oil, gas, and water, and that gas then goes towards the inlet receiving. And now we will see that what is the inlet receiving, what can we do, and after that it goes to the compression. And as you can see in the block diagram, it goes for the treatment where we remove the impure gases like H2S, CO2. We remove the water here. Then we have the hydrocarbon recovery, heavy hydrocarbons. We call them NGLs. Then we remove the nitrogen. Then we have helium, and we send the crude oil there. We we send the uh, gases, natural gasoline here, NGLs there, and the CO2 we separated, sulfur we separated, and so on. And after the nitrogen rejection, we compress the gas, we send to the sales gas, or we convert into the liquid form, or we send it. Now, this is a very comprehensive diagram of the natural gas processing. It is not necessary that if every plant should have it all or must have it all. Every plant, it's not necessary that the plant we have in Danagas should must have all of this. No, or the plant somewhere else in Australia should have all these processes as mentioned in this diagram. No, it all depends on what is the composition at the inlet receiving. Tell me one thing, like for example, if the gas we are processing it has no water, then what is the point to put dehydration? Or if the gas here we are processing it has no heavy hydrocarbons, so then what is the point to put the hydrocarbon recovery? Or if it has no nitrogen, then what is the point? So our plant that we make, it all depends on the composition we receive and the inlet receiving. That's the most important thing right now we can start with. Now the first step is the wellhead, and I'm sure that since you are taking a senior course here, so most of you have seen the wellheads in reality. So you can see here in the wellhead actually we have a Christmas tree. From here we have these DCS operated hydraulic valves, and then we have lots of pressure and temperature sensor, and the gas goes through here. This is a simple wellhead diagram, and and this is from where this gas comes out of reservoir using this Christmas tree, and it goes on. So let me show you first a video of wellhead and see how it all goes.
Here you are. This is what they call it exactly wellhead. Okay? This is what it likes. This is what they call Christmas tree. You see it? It's actually a set of valves, different subjects to do. You see? Spool or the skin of wellhead. That's the rotary actuator. You see that one? This one is the rotary actuator. This is actually a valve, cement engine valve. It's like you see here. this is the rotary valve. The rotary, you see the gauges, pressure gauges on it. Read it now. Everything. Oh, this is so hot. This is working now. This is a working flow line. You see that valve, that pressure gauge over there? Everything is fine.
So this was the just general introduction of the wellhead. You can see here we have the Christmas tree and the gas is coming out of rotor. Here we have the pressure and temperature gauges, and then the gas flows from here, and this is the rotary valve. From there we control all this hydraulically operated uh, valves. Now let's look at some.
Hello. Okay. Here we are. Rumaila oil field, Basra. This is another actually wellhead area that I decided to show you the criteria and different designs of wellheads. Sometimes you see this is a 6-inch pipe, and the temperature of the oil coming through this pipe is should be like 150 Celsius degrees. Yeah, because if you touch the pipe from outside, after 2 seconds it will burn your hand and you cannot bear it anymore. So it should be like that. You see right here the wellhead. This is another pipeline goes through this. Okay, wellhead area. You see it's kind of big wellhead. Yeah. Here we are, how it's looks like. Okay. You see right here, this is Christmas tree. All of valves on it. 2 master valves. Another, I'm not sure about the names. I can count it for you. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, this at least 8 valve on Christmas tree it has. You see even the voice of the oil going through the pipe is coming, and I'm gonna show you the pressure and temperature on the gauges we have here. You see that's also a master valve on the line. This is also a rotary, electrical control valve. That's self-control. It's check valve, I think. Yeah, pressure valve. It's going to control the line about the pressure. If the pressure comes more than a specific pressure.
Let's pause it here and move ahead with our lecture. Well, so we say that we have the wellhead here, and when the gas or oil are together, when they come out of here, they goes to the separator. This is the main job that we do. Now, after that, we have pipings. Here you can see here. Now, for example, if the reservoir has 10 wells like this one, 10 wells or 12 wells, or let's say 5 wells or 6 wells, they have to gather together, and we gather them using the smaller gathering pipelines, we call them. So we call them small gathering pipelines. Okay, and they will, if you look at it, they will. So for example, we have how many wells? 1, 2, 3, 4, 5. So these are the pipelines that we have. And when the component product, whatever it has, gas or oil or something, together, they go together through this pipeline and mix together using the manifold into the one big pipeline, which goes through the separator. That's what actually goes on here. So Oil and gas from field, the well I showed you actually, that's the oil and gas from field. It goes through the separator. I've Okay, one separator, two separator. Now this depends on how many separators you need. One, it depends on the pressure, temperature, and the level of separation you need, or level of product you need. So these are the gas oil separation processes that we do. We have one separator, two separator, and then we have the low pressure separator. Okay, once the yes, so after the separator, the gas the gas from here goes to the plant, and the liquids or condensates then go through two different process, and we store the crude oils. So crude oil from the down, gas from the top. Nowadays we have four-phase separator. Even we consider the solids nowadays, and so on. So in the inlet operation, well, when the gas come out of the wellhead or Christmas tree, as I showed you in a video, after that it goes through the separator, as I showed you from here. From here it goes to the plant. Then when it goes to the plant, it starts from here. And the first thing we have the inlet scrubber. Here we have. And what is the function of inlet scrubber? I will show you that. The scrubber actually are used to remove the condensate if there are any liquids remaining, or maybe the efficiency of separator was not that good. There are in the gas there are still some liquids. So these liquids are removed using these inlet scrubbers. That's the main purpose of it. So either we can re-inject them back, or we just put them in the truck and send them. This is what we do. Also for this plant, we need, after the scrubbers, we compress it. We have a heat exchanger, because when you compress the gas, it generates lots of heat. So we can send this gas to the plant for further processing. But at the same time, what we do, we put the hydrate inhibitors, and we put the corrosion inhibitors, and we have metering also at both sides. And if we have any, sometimes we put the condensates back if needed. Okay, so now in the main diagram, we remove the liquids from here, you compress it, compressor makes the heat, then we have the air cooler which actually reduces its temperature, then gas goes to the plant. At the same time, we inject the hydrate inhibitors and corrosion inhibitors. That's the main inlet operation diagram. Then let me show you a video on it.
A natural gas compressor station like we're at here today is a transmission relay station. We have thousands of miles of gas transmission pipeline in the Northeast. As the customers take gas off the pipeline system, the pressure is reduced. So we have to add the transmission relay compressor stations to boost the pressure in the pipeline. It comes in through a suction line into the compressor station. It goes through a filter separator element that we have that takes out any impurities that might be in the gas. The compressor basically is driven by an engine, in this case a turbine. The gas goes into the compressor, it boosts the pressure when it's in the compressor. It goes back out into a discharge line from the station. It goes back into the main pipeline on a downstream side at a higher pressure. We've gone to primarily utilization of solar turbine. Solar turbines, from our standpoint, are state-of-the-art equipment. They have what they call a low emissions package that Dominion buys from them. It's a gas-fired turbine engine that drives the compressor. And by process of burning the natural gas to create the power to turn the compressor, the actual exhaust goes through an oxidation catalyst, which further reduces the emissions. To the fact if you're standing at a natural gas compressor station and you're looking at the exhaust, you see no emissions. There are no emissions visible at a natural gas compressor station. The facility is operating at 100% capacity while we're standing here talking. As you can see, I'm talking in a normal tone of voice. I'm not having to raise my voice. The building is insulated. The exhaust itself is also covered with an insulation that basically mitigates the amount of noise coming from it. The amount of noise that's at a compressor station outside the fence of a compressor station is really very similar to what you would have if you're in your residential plan, standing in your front yard and a car goes by. I mean, that's essentially the noise level that you're going to be hearing. Here at Dominion, safety is our primary core value. Everything we do is focused on safety. The facilities are monitored on a 24/7 basis by our gas control operations in West Virginia. We have people on site every day monitoring the facilities, checking to make sure everything is working within the right parameters. We do a lot of inspections to ensure that all the controls are in place and functioning properly. We have what we call an emergency shutdown system at our compressor stations, and what that does is it basically can shut the main valves coming in and out of the station, such that the entire station can be isolated from the pipeline. From our perspective, the safety of our employees is paramount. We want them to be able to come to work every day safe and go home every day safe. Not only just themselves, but their friends and family that live with them in the community as well. The operation of a compressor station is really contingent upon the customer requirements at any given time. Typically in the winter, there's a lot of natural gas required for the heating load. So the natural gas compressor stations operate fairly frequently during the winter operations. During the summer, now
Clean-burning natural gas is an abundant and vital source of energy that we use every day in our homes, schools, and businesses. And equally important is how natural gas is safely and reliably transported, which is where we come in. Natural gas transmission pipelines are proven to be the safest form of transportation and the most reliable way to transport natural gas from where it's produced to where it's consumed. But you can't just put gas in one end of a pipe and expect it to come out of the other end miles away without giving it a little push here and there. Compressor stations give it that boost along the way. Inside each, there is an engine, somewhat like the engine in your car, just bigger. And instead of turning your tires, it turns a compressor that propels the natural gas onto the next compressor station, 50 to 100 miles away. Our systems employ a number of low-emission technologies. As a result, our compressor stations achieve air quality ratings below state guidelines. Our compressor stations are also designed to minimize noise with highly engineered, soundproofing materials and mufflers. The noise from a compressor station is less than 55 decibels at the station's fence line, which is about as loud as a modern-day dishwasher and many other daily activities. We value safety above all else, and our compressor stations are engineered, built and operated in accordance with the highest state and federal regulations. Stations are equipped with safety features such as automatic shutdown sensors and other devices. From our control center, technicians monitor the status of natural gas pressure and flow, valve position, and other safety sensors. They will remotely shut down the facility if necessary. Additionally, we work closely with first responders at all levels to ensure they're aware of our operations and can promptly assist the community in the unlikely event of an emergency. We do all this to ensure our compressor stations are operating just as they're designed, safely and reliably.
So this was the compressor operations that we talked about, and now we will go ahead and look at what is picking. Well, picking is the process of forcing a solid object through the pipeline. So it's like a rubber pipe which goes through the pipe, and purpose is to clean the pipe from inside. So it's like what we do, we put it inside the pipe, we call it a pig also, using the pig launcher, and we remove any debris or anything, any wax or any material inside the pipe to clean it. Let me show you how it looks like. So these are the rubber materials, look at them. So they go through inside the pipe, and the purpose is to clean them first of all, remove debris like dirt, wax and solid. This is the main objective there, such as dirt, wax, lines, or if you are sending two different products, so it provides a barrier between these two products. Also, it checks the wall thickness, any damaged section inside, sometimes to do the survey of the inside of the pipeline thickness, to check the corrosion and so on, to check the inner coating with inhibitors, So these are the main functions, and I'll show you now the examples of picking also. So we have to carry on this picking operations usually, and let's see first what they are.
Pipelines are the safest and most efficient way to transport energy. Crude oil, gas, and petroleum products are all transported via thousands of kilometers of pipelines across the world. Pipeline owners and operators work to prevent pipeline failures by evaluating, inspecting, and maintaining their assets using integrity management programs. One element of integrity management programs is pipeline inline inspections. Conducting inline inspections with gauges or tools, commonly known as smart pigs, using the magnetic flux leakage technique allows pipeline companies to safely check for external and internal defects, dimensional abnormalities, and corrosion in pipelines. Utilizing these tools to examine the structural integrity of pipeline systems can protect workers, the environment, and surrounding communities. Intertek helps companies remain compliant while assuring asset safety and reliability. Intertek's pipeline integrity management team, supported by a strategic technology partnership with USA-based Q Inline, uses state-of-the-art inline inspection tools that are designed to meet the most challenging inspection needs. Through our partnership with Q Inline, we are committed to providing a high-level service and continuously developing new technologies, utilizing their extensive knowledge and experience to provide this service to pipeline companies in China. Our personnel are well-trained and have been qualified by Q Inline in the USA to serve our clients locally in China. Our equipment is located and maintained in China for ease of scheduling around planned pipeline inspection windows. Pipeline inline inspection tools are intelligent by design and rely on magnetic sensors, expandable dimensional inspection calibers, and GPS or alternative location devices to map data when performing inline inspections on pipelines. The sensors provide technicians with valuable data that can be analyzed to determine abnormalities or weaknesses in the pipe and identify any potential safety hazards. The data can then be used to determine whether repairs are needed or whether a section of the pipeline needs to be replaced. The inspection tools are deployed into the pipeline using devices called launchers. The launcher is connected to the main pipeline and can be isolated from the main flow of product. The launcher is drained and the inspection tool is loaded through a hatch at the end of the pipe. The pipeline product pressure pushes the tool through the pipeline to gather data at varying speeds depending on the pressure in the line. The inspection tool works by using high-powered magnets to create a continuous circuit within the pipe wall to detect magnetic flux leakage. Magnetic flux leakage is a magnetic method of non-destructive testing during which powerful magnets are used to magnetize the pipe wall. When the inspection tool encounters an abnormality such as excessive corrosion, a change is detected in the magnetic flux patterns, which is detected by the sensors and stored within the tool for evaluation once the inspection is completed. After the tool has completed its journey through the pipeline, Intertek technicians download the data from the tool for evaluation. The data is analyzed to determine if and where repairs need to be made. Technicians can provide feedback by selecting and prioritizing indications that need repair to make sure customers are compliant with industry standards and regulations. Intertek provides equipment and qualified technicians to conduct inline inspections locally in China, which ensures speedy delivery of services. Intertek operates inline
Ample is an automatic multiple pig launching system that minimizes the number of times a trapdoor has to be opened to access pipelines for pigging. This makes it particularly beneficial for unmanned platforms, isolated launch sites, subsea pigging, or high-frequency pigging. It also greatly reduces the potential for accidents to personnel operating the trap. Normally, existing launchers do not require modifications to use the Ample system. Also, no external power supply is required to launch the pigs. Pigs are preloaded into a simple cassette. The cassette is inserted into a launcher and the closure door shut. Here we can see product in the pipeline bypassing the launcher. The first pig in the cassette does not have to be an ample pig, as is shown here. Subsequent ample pigs are interlocked and ready for release using a trigger mechanism mounted on the pig. The launch process is activated by the operator either locally or remotely. The kicker line and vent line are opened. The trap is vented and product flows into the launcher, which bypasses the ample pigs. The pressure rises, and when the launcher is full, the vent line and kicker line close. The pig trap isolation valve opens, and the kicker line valve reopens. The first pig is now launched, and the pig signaler trips as it passes. The pig trap isolation valve and kicker line valve close, and the launcher is then depressurized, drained, vented and purged, ready for the next launch sequence. With a predetermined pressure drop in the launcher, a trigger mechanism on the next pig is armed. This mechanism then prevents product bypass, and this pig is now ready to launch. Meanwhile, the first pig continues along the pipeline. Using ample pigs does not affect the pig's cleaning capability. The pigs can also be fitted with a range of equipment such as jetting heads, brushes, magnets, isotopes and pingers. As the pig approaches the receiver, a signaler trips. The pig enters the receiver. The pig trap isolation valve closes and the trap is drained. The closure door is opened and the pig recovered.
So that was all about the pigging job. These are some pig launchers, different types of pig launchers that we have depending on the size of the pipe, diameter of the pipe. Here are they. Here you can see first what can we do. This is the launcher. We put the pig here inside, then we have the valve. We open it, then pig goes directly. Then after at the receiver, after it finishes its job, the pig reaches go here. We close this valve here, then we can take it out. So this is the inlet and outlet, and here's the YouTube video that you can find out the inlet receiver. Then there's one more thing. Let's talk about the separators. Separators are two kinds: vertical separators and horizontal separators. Here we have. So it has the vortex breaker. We have the gas, liquids. You can see these two type of separator here. We have then three types of separator, where the gas goes from the top here, and then liquid phases, hydrocarbons goes from here, and so this is the typical three phase. If any water vapors aqueous here, it goes down here, hydrocarbon goes down here, and the gas goes down from here at the top. Okay, then there is another important inlet manifold operation is the slug catcher. The purpose is, for example, if there is a liquid drops inside the gas, and if this gas with the liquid drops goes through the processing plant, it can damage the processing plant. How? First of all, the water can cause the corrosion. Secondly, it can cause the the vacuum, the bubbles inside the compressors and in the plant. So in the end, it can malfunction and it can stop all the operations. So we don't want this water to go. So what we do in this case, we use these slug catchers also. There's a special term that we have here. We call it a slug catchers. That's what we use it. So I will show you now how the slug catchers look like. You can see slug catchers are actually it's a pipe. It's a pipe and four different pipe. We just cross the gas from here, and if there is any gas, the gas is separated from here. You can see here mixed gas inlet goes here, and then it goes through these pipes, and if there is dry gas comes out, and the liquid, then liquid storage goes straight from here. These are the slug catchers. These are the slug catchers. So let me show you. So you can see now it has a gas and some liquid. So the liquid is actually trapped here. simple. So now you see here it becomes two-phase. The gas is separated and liquid is separated. The gas goes from the top. So liquid is going down and gas in. So it's just we are just taking advantages of the mechanical design here actually. See how it works. So now we have a gas and liquids are down. So we call this equipment called slug catcher. It catches the slug or catches the liquid out of it. Let's look at it again. So here it becomes two-phase already. The gas is going up. So because of gravity, the liquid particle fall down again back here, and the gas is now clean. And the gas goes up, and liquids goes down. It's a very simple mechanical design. Yes, so these are slug catchers. So they protect the plant from large and sudden liquid influxes, and as I said, purpose is to remove them from there. Then we have another issue in the gas. If the gas has some water, or it can cause hydrates, and hydrate is like an ice that is crystal like material, is like in your refrigerators you have a white material. So same kind of material can be formed using this gas, and this gas is made of methane, so it can burn even also. You can see here it can catch the flash. So it can be very much problematic in these hydrates, and we have to make sure that we remove these hydrates from here. So what are the gas hydrates? How we define them? These are the ice-like solid materials which can form well above 32 degree Fahrenheit. And what hydrates consist of? Nitrogen, oxygen, C1 through IC5. So it can be flammable. Propane contain is the major factor. So it can be flammable. At the same time, it reduces the diameter to flow, and it reduces the for our product to transport from one place to another place, and we don't want this kind of hydrates form. Well, what are the main prerequisites for hydrates? Well, the main things that are needed for hydrate formation is the temperature, water. These are the two main things, that and water and temperature. So it has to be temperature and pressure equilibrium, and equilibrium using the temperature and pressure. But we don't know that if once it is formed, how much it can be. For example, here you can see that it just blocked all the pipelines. See all the so what oil or gas you can flow from this pipe, because all is made of this solid hydrate, so we cannot do anything out of it. So it's quite unpredictable, and that's what is our job, to predict this hydrate formation. For that we have some methods. You can see here we have gas gravity curve, and they are predicting that based on pressure and temperature, that at what pressure and temperature this hydrate formation can happen. So how can you avoid this hydrate formation? Actually, you have to make sure that your pressure and temperature is below that. For example, temperature should not be too cool, and secondly, there should be no water, so you have to dehydrate the gas and add the inhibitors. Inhibitor means those chemicals that can inhibit or reduce or stop the hydrate formation. So gas, this kind of hydrates are found inside the membrane. What kind of gas are they?
Oh, beautiful.
We don't want this toxic.
Are you doing the
Here you can see we are doing the lab experiment and see how the hydrates are formed, and when the equilibrium is lost, you see this white material here. The hydrates are formed here. You can see here all our hydrates are formed. Now these hydrate formula, it's anhatic. We don't want it. It reduces the diameter, cost us money, cost to remove it, and we have to clean the pipeline, stop the operations for a while in order to remove those hydrates from the pipes, especially in offshore. And if these hydrates are formed inside, let's say separator malfunction. So in offshore, it's a more problem in offshore wells, offshore reservoirs. Well, how to prevent it? First, work outside the hydrate region. This should be the main advantage. And remove the water. This is the second advantage. Well, it is quite impractical. There's still some water which remains, or add inhibitor. So these three methods: prevent hydrates, work outside the region, remove the water, put some inhibitor. That's what you can do. And methanol is kind of used. MEOH is used to for, and this is the KL low dosage, and these are some of the inhibitors that can be used to remove the hydrates formation. Okay, so what we talked about the wellheads, we talked about the slug catcher, we talked about the hydrates, we talked about in general pigging, what are those operations. So these are the basically inlet operations which they are done at the gas processing plant. So now let me show you some pictures here. Look at this. This one is the gas well with condensate tanks and fired separators. This is the booster compressor 1, 2, 3, 4. This is the pig launchers area. These are the inlet receivers with pigs. These are the pigs that I showed you. These are the slug catchers. Inlet receivers. These are the storage tanks or separators. Here. This is the slug catcher actually. You see, as I showed you in a video. These are the slug catchers. You can see these are the small storage tanks, and this is the well here. This is the metering and the gas well here. Separators, pig receivers, pig launchers. So that's all about the inlet operations. I hope you got some nice information out of it. In the next lecture, we will talk about the maybe sweetening plant. Thank you and see you in the next class.